Hello, folks, and welcome to our quick dissertation on how to solve the matrix of print, aka defining the ink equation. We put this together for two reasons primarily. First and foremost is to help the printer ultimately produce the best possible finished product for their customer. And then secondly, to do so as efficiently as possible. In our over 20 years of experience in the print market, doing audits, just working with people in general, we've identified that in a lot, if not most operation, there are thousands, if not millions of dollars available in savings via wasted substrate and downtime. That by utilizing ink as a tool and answering this ink equation, you can eliminate some, if not all of it, and again, produce the best possible end product for your customers. So without further ado, let's get started. Let's start by just identifying the ink equation itself. That is job details plus volume plus substrate minus limiting factors equals ink formulation. So step one, job details. What are you printing? What are the details of the job? And what, most importantly, what is the end product? What's the expectations of the end product? What is your customer going to get at the end of the day? And how does that end product need to perform in whatever real world scenarios it's going to be involved in? What these details are going to do for your ink formulation is create a foundation in where, to start, there are thousands of different vehicle/polymeric combinations in conjunction with pigments, in conjunction with additives to produce the best end product possible. But the more we learn about the job itself, the better we can narrow down and dial in where to start as an ink formulation. So additional details such as how many colors are there to print, obviously. Is there fine print? Are there dots? Is there screen work? Is that screen work potentially interconnected with line work? Are there traps? And if there are traps, what colors go down first? Are we going to be coding? And then again, specifically, what are the end product resistance characteristics that we need to know about to create that fundamental starting platform from an ink formulation? So job details get the ink formulation started with the end product in mind. Now let's dial that in and make it as printable as possible. So secondarily are the volumes of your analogs. Determining the actual volume of the analogs will allow the ink formulator to accurately nail down pigment loads. Nailing down pigment loads on the front end is going to allow you to achieve your desired color, best case scenario possible. Most, if not all, ink companies should or are equipped with highly sophisticated proofing equipment in the lab to where if we interconnect that equipment and correlate it to the real volumes of your analogs on press, we can put together the best possible polymeric construction of the ink. Again, nail those pigment loads, dial in what additives we need, ensure our drying speeds are best case scenario based on your volumes. If in fact we have trap work, we can interconnect all those things within every ink formulation, but it all starts with volume. I do want to note that you can get volume measurements, accurate volume measurements from most of the awesome analog companies that are out there, analogs companies that are out there in the market. And/or there are companies that simply do those audits on the side. Communicating that information with your ink supplier allows them to dial in the important characteristics of the ink to get you pulling up right, efficiently, with the best quality possible, consistently. Third piece, substrate, the foundation of the product. Are we printing on paper? Are we printing on film? Are we printing on foil? Obviously. And then thereafter, what specifically about the paper makes it what it is? What's the pound weight? What's the surface look like? By knowing the details of this substrate in conjunction with volumes and what the job is, the ink formulation can formulate around creating the best lay possible, the best color consistency, the best pop in color, the best rub resistance, the best runnability, so you can achieve the highest speeds possible once we've interconnected the substrate you're running on to the volumes you're laying down to ultimately the job we want to create. So that's the third piece. Now, to end this as quickly as we possibly can, to get to the limiting factors, what limiting factors are. These are the obstacles we face either within your operation or the conversion of the material or whatever individual property resistant characteristics they are, what's expected of the end product. And knowing and communicating the limiting factors with your ink formulator, it allows them to take a good ink, to a great ink, basically. There are all sorts of limiting factors. I'll list a couple and explain. Essentially, are there inadequate components of the press? Maybe that's airflow. Maybe that's heat restrictions. Maybe that's converting restrictions. If you're printing boxes, are you die cutting in line? And if so, what are the drying and rub characteristics of the ink need to be to get through that process? Thereafter, how does that interconnect to the job details and the volumes, and all of it works together to produce the best product possible? Is there specialty rub resistance characteristics desired of the end product? And if so, what's that done to our selection of polymeric and vehicle components? And it, again, in conjunction with the volumes, what do the drying speeds need to be? So all of these limiting factors, are there pumps that act up and create foam? And does creating foam based on the substrate alter how well we lay or how well we dry or how clean we print? Taking the limiting factors that might exist within your operation and creating an ink around those in conjunction with what we want to create inevitably, and then thereafter creating training processes around those limiting factors that might be necessary for optimal performance. So guys, to recap very quickly, the ink formulation, job details plus volume plus substrate minus limiting factors equal ink formulation. I hope you've enjoyed this quick piece. We're going to be posting more material out there and kind of keep this rolling. We hope that everybody takes advantage of it so that together we all continue to sharpen the saw, be the best printer converters that we can be. And that's it. Thank you very much and have a wonderful day.